The only reason I ask for the explain is if you just guess. Because you could just guess and put stuff down. So the intent is that there's two ways. It's, did you actually know what you were writing when you wrote your numbers down? Just tell me that. Or did you just guess? So it's trying to find a balance between testing you on the concept and then preventing just random guessing from it. Okay. So when we go through and discuss it, it's going to come back to explaining how. Okay? So first thing we should go through and do is evaluate which hydrogen are we looking at. So in each of those, we should identify the most acidic hydrogen. And the first one, where is it? It's the only one. I didn't say it had to be difficult. The next one, there's two hydrogens, but they're the same thing. Next one.
One attached to the nitrogen.
Okay, so right there, by telling me the one attached to the nitrogen, you've actually already started ranking. Why is it the one attached to the nitrogen?
Because the nitrogen is more electronegative.
Nitrogen being more electronegative than carbon, we would expect the hydrogen to be more acidic from that one. Why does that make it more acidic?
It's more positive.
Why is the hydrogen more positive? Which you already said. The nitrogen's more electronegative than the carbon. Okay? And what you're doing is when we go through the order of ranking acidities, the first one we had was size, the next one was electronegativity. Carbon and nitrogen are in the same row, no size difference, it's just electronegativity. Okay? When we move to the next one, which one's the most acidic?
None.
Again, it doesn't matter. And the last one, there's only the hydrogen. Okay? So we could go through and start pretty much anywhere we wanted. Okay? You already said that the nitrogen with the hydrogen was more acidic. So our third one was more acidic. Sorry. The hydrogen attached to the nitrogen was more acidic than a hydrogen attached to a carbon, which means we actually already established the relationship between the two right next to each other. Okay? We would expect that one to be more acidic than the other. Okay? We can't put any really numbers associated with that yet because we don't know where they are relative to everything else. Okay? Since we've started there, we could continue to work from there, but it's ultimately up to you. Okay? Where do you want to move to now?
Water.
Okay, we could jump to the water. Why did you pick water?
Because of the oxygen.
Okay, what about the oxygen? How is it
more electronegative than nitrogen and carbon?
more electronegative than the nitrogen and carbon? And as an added bonus, what's the difference in size?
Bigger.
What's the difference in size between oxygen, nitrogen, and carbon? Within the same row, we're saying that those differences are virtually negligible, which means no difference in size. The only thing that's changing is electronegativity. So more electronegative, more acidic. What does that mean? Oxygen is more acidic than our nitrogen. Okay. So now we've got two more options, HCl and HI. Okay. Again, pick one. Which one do you want to pick?
HI.
Okay, we could jump to HI. Do you know anything about HI right off the bat? It is a strong acid. So it's already going to be more acidic than the other three. Okay? So we could put that up really, really high. I don't know that I can rank this easily. Let's just say more than oxygen, nitrogen, carbon. Okay? We didn't really explain why it was more. We just know that it's a strong acid. Okay? In this case, we can kind of sneak away from that and dodge that question. We'll come back to answering that in a little bit. Okay? So we've now established that HI is more acidic than the oxygen, nitrogen, and carbon. The last one we've got to look at, HCl. What do you know about HCl?
Strong acid.
Strong acid. So it's also more than
Carbon, nitrogen.
our oxygen, nitrogen, and carbon. But what's its relationship to HI?
Look at their size.
Now we've got an issue where we have to go through and evaluate differently. The difference between chlorine and iodine is size. Size was our primary concern when trying to evaluate its acid strength. Chlorine is smaller, which means what about its acidity?
Less.
Less acidic. So now we could go through a number. We would expect HI being the strongest. I don't remember how I set it up in numbering for that, so we'll just say strongest is HI, followed by 2, 3, 4, 5. So then the question after that asks for you to explain. A was explain the ranking of the two most acidic compounds. Why was HI more acidic than HCl?
Size.
Iodide is bigger than chloride. It can stabilize the negative charge or conjugate base better than chloride.
So what can stabilize?
Because it's bigger, it can stabilize the negative charge, the electrons it's taking away from hydrogen, better than chloride, because it's spreading them over a larger area. Okay? So it's a stability of the conjugate base. Iodide is a more stable conjugate base. Yeah. Okay? So I guess I could write that down. Iodide is a more stable conjugate base to bigger size.
And for bases, a more stable base is a weaker base, correct?
A more stable structure is
Yeah.
weaker.
Okay.
So you're trying to quite like your phrasing there, but yeah, the more stable the structure is, the weaker it is. Part B said why were the last three ranked the way they were. Okay, well, what was the difference between those? Oxygen, or O negative, holds a charge or holds negative better than nitrogen, better than carbon, because why? Oxygen is more electronegative. Okay. And nitrogen's better than carbon because nitrogen is about more electronegative. Right? So it's just a question of establishing what those differences are and writing them down. One of the big things that we can look at in this case is in both of these explanations, you'll notice that I said, or started off my answer with I minus and O minus. Why minus?
We're looking at the conjugate base.
We're looking at the conjugate base. So when we're ranking acid strengths, we're ranking them based on the stability of the conjugate base. So if you're trying to determine which acid is a stronger acid, you look at the conjugate base. Okay? So if, like on exam 3 where I asked you to draw the relevant resonance structures, the relevant resonance structure is going to be for the conjugate base. When you draw out the conjugate base, why is one more stable than the other? Okay. That explains your acid differences.
So the more stable the conjugate base, the stronger the acid.
Yes. The more stable conjugate base generates a stronger acid.